Tires are highly technological composite products that incorporate over 200 different material components, each contributing specific functionalities such as air retention, cohesion, energy dissipation, and many others. Now, these materials are also very varied in nature. They include rubber mixes obtained by combining specifically engineered polymers with specialty carbon black or silica fillers. They also include a number of flexible reinforcing substructures made out of steel or textile, and they even include, in some cases, specific high-performance hybrid cords. Now, thanks to this flexible and composite structure, tires are capable of responding to a broad range of often antagonistic requirements. Think about it. You want your tires to be more resilient, last longer, be more robust, but at the same time, you want it to be as light as possible so as to require less raw materials. You want it to be able to dissipate more energy when braking so that it can help your car stop faster. But you also want it to dissipate less energy when rolling so as to have less impact on your fuel consumption. You want it to be able to sustain higher conditions of loads and temperature, especially for commercial applications. But at the same time, you expect it to behave and perform just as effectively under those extreme conditions. And of course, for Michelin, all these challenges must be met with a profound commitment to reducing the tire environmental impact. Now, for over 130 years, we have demonstrated through many examples how, in order to overcome this apparent antagonism, the only way is through technological innovation. Well, we believe, and have many examples to show for it, that in order to sustain such a level of innovation, there are at least three essential conditions that need to be met. First of all, you need to have a profound knowledge of your raw materials, their characteristics, their capabilities, and always be on the lookout for new candidates that might provide new and differentiated characteristics. Secondly, you need to master the transformation of these raw materials into semi-finished product and substructure, such as steel belt packages, for example. And you need to be able to do that throughout each step of the manufacturing process. Thirdly, you must be able to assess qualitatively, but also quantitatively, how each component within the tire is going to cooperate and interact with adjacent materials and substructures in order to respond as effectively as possible to the conditions of use that are resulting from our customers' experience our products. Because of these three conditions, we made the very distinctive and deliberate choice that every time a material domain provides lasting and significant advantage and differentiation in terms of tire performance, we should integrate upstream into that domain. So, for example, we integrated upstream into the research and development and production of our own specialty elastomers. We integrated in the development and conception of our mixes, and we even developed some of our own specific high-technology reinforcing solutions. We also made the choice to develop our expertise in using simulation and analysis to understand how driving conditions translate into very specific operating points and operating conditions for each material inside the tire, so as to be able to optimize those materials for these operating conditions. Lastly, in order to achieve cooperating composite structures, you also need cooperating experts. each at the peak of his knowledge in his domain or her domain, but also capable of working and interacting with other experts in chemistry, biochemistry, mechanical engineering, data analysis, mathematicians, so that each of them can then go on to challenge the assumptions and paradigm in each other's field, and by working together, come up with truly revolutionary solutions. We believe this really sets us apart in the way that our scientists and engineers work, cooperate, and expand their knowledge. In summary, it would be quite accurate to describe the scope of our research as providing innovations for structures that must meet requirements that are at the same time critical and antagonistic, and which leads them to becoming increasingly lightweight, resilient, capable, and sustainable. It would also be equally accurate to say that our distinctive capability, what really sets us apart, is the ability to find such solutions by organizing the cooperative behavior at a multi-scale, and I mean by that from the molecular level all the way to the full structure, between a broad range of high technology materials. Materials are at the heart of our business. Once framed in those terms, I believe it becomes quite obvious that these unique capabilities can be used, of course, in tires, but also beyond tires, and serve as a lever for growth in the broader domain of flexible composites and high-tech materials.
Definitely, our know-how in tires can be leveraged in all our high-tech material activities. These activities consist of 4 ecosystems. The first ecosystem is about the ecosystem of sustainable, flexible composites. The second ecosystem is the ecosystem of 3D metal printing. The third ecosystem is the ecosystem of hydrogen mobility. And finally, the fourth one, and probably the newest one for Michelin, is the ecosystem of biocompatible devices for regenerative medicine and cell and gene therapies. So all these activities are very diverse, and they are all developing their products and their activities in many different vertical markets. All these products require material science and material innovation in order to fulfill very specific customer needs in niche markets or emerging markets, and also to be able to face very challenging usage conditions. The first ecosystem we address is the ecosystem of sustainable flexible composites. A sustainable flexible composite is made of elastomeric matrix, resins, and reinforcement, and is able to face tough usage conditions. And in fact, the tire is the most complex flexible composites. As already mentioned, we've been working on the whole value chain of the tire production. And we have developed a deep knowledge of all technological bricks that can bring additional performance or additional sustainability to our tires through innovative raw materials or innovative semi-finished products. These innovative raw materials or innovative semi-finished products can then be used also to increase the performance and the sustainability of our flexible composites. These raw materials and these semi-finished products can also be used in other type of products, different from tires or different of flexible composites, and they can be sold into new markets that we are going to enter. Let's take some example, and let's look at the first level of the value chain, the innovative raw materials. We are able to produce recovered carbon black and recycled metals from end-of-life tires. And for that, we are using a very innovative technologies, pyrolysis technologies, with a partner, Enviro, with a Swedish company. And with Enviro, we have recently announced that we are going to build a new generation recycling plant in Chile. Other example is about the recycling of used plastics, like yogurt pots, for example. And in fact, with another very innovative technology, with a partner, a Canadian partner called PyroWave, we are able, in fact, to cut into basic constituents, the plastics, into styrene. And with this recycled styrene, we are able to produce again polystyrene and plastic. And this plastic has the same qualities and the same performance like virgin plastics. Let's look at the second level of the value chain, the semi-finished products. With high performance and not toxic resins we have developed for our own usage, for our own tires, we are able now to adapt these products and to sell them thanks to a company called Resicare, which is a Michelin company. And we are able to sell these products, these resins, to another industry, to the wood and plywood industry. And here what do we see? We see that in fact these resins are also high performance for this application and are also non-toxic. One, they are used when producing the wood, but also in the future when the wood will be transformed into furniture. So you see as well the example of semi-finished where we can move from tires to another incredible industry, wood. The third level of the ecosystem of flexible composite is a level of finished products. And here we have two examples. The example of rubber goods from Fener activities, advanced sealing technologies, of precision polymer activities, and here it's about belts, seals, hoses. The other example is a very recent example of air cushion systems we developed for medical usage. This has been developed by our R&D teams with hospitals during the COVID crisis. So you see in this first ecosystem of sustainable flexible composite how we can leverage our R&D technologies, our R&D expertise in materials, and how we can apply them to the different of the value chain of flexible composite by selling, in fact, innovative raw materials, innovative semi-finished product, and innovative final products. The three other ecosystems are the ecosystem of 3D metal printing, the ecosystem of hydrogen mobility, and the ecosystem of devices for regenerative medicine. And in these three ecosystems, we are, in fact, with markets that are emerging and that are very promising. And here, definitely, we can leverage our R&D expertise. And we have, in fact, to find partners with whom we are going to team up to accelerate the development of these activities. Let's look at 3D metal printing, the second ecosystem of high-tech material activities. So in fact, we have developed this technology many years ago, 15 years ago, for our own usage, for our own tires. In fact, to produce the sipes for the curing molds of our tires. And we have developed a strong knowledge on how to produce parts with 3D metal printing. And we decided to bring this technology to the market. And we looked at a partner, Philippe Machining, in order to create a joint venture, AddUp, and to together develop different offers. That could be part production, that could be also machines of 3D metal printing, and also services to help our customer to adopt this new technology. I encourage you to join the dedicated workshop on 3D metal printing to better understand our ambitions in this area. The third ecosystem in high-tech material is about the hydrogen mobility. A very attracting, very developing, very growing market that is going to really transform the mobility into decarbonized mobility. And this is a key stake for the decarbonation of mobility, and this is a key stake for Michelin. And here, in fact, again, we have developed this technology many years ago at Michelin, leveraging our expertise in elastomers, in surface physicals, and we have decided again to team up with a key partner, Faurecia, and we have created a joint venture that was created 1 year ago, Symbio. And here again, we are going to develop our activities, leveraging our R&D expertise. And I encourage you again to join the workshop on hydrogen in order to better understand our ambitions and our priorities in these activities. Finally, the fourth ecosystem, and the newest one, as already mentioned for Michelin, is the ecosystem of medical devices, biocompatible devices for regenerative medicine and for cell and gene therapy. This is an activity that was coming through the acquisition of Fener, and this is a Solesis activity. And here again, this is a very promising market with high level of growth. And here again, we are able to leverage our expertise in materials in order to accelerate the development of these activities. So on all these high-tech material activities, we are able to leverage our R&D expertise and our material innovation, like we do in tires. Our aim is then to expand the applications beyond tires and to expand the application in order to better leverage our R&D technologies and to create additional value for the group.
So all this progress in high technology materials will in turn come back to nurture our leadership in tire. Remember that tomorrow tires will need to meet a whole range of new requirements so as to contribute to the ongoing transformations of mobility. This we have embodied with our vision concept that was introduced 3 years ago at the Moving On Summit. It is a polar star for the tires for tomorrow's mobility. It is a tire which is airless, rechargeable, connected, and 100% sustainable, meaning made out of biosourced or recycled materials only. Now, each of these dimensions will require breakthroughs in high technology materials. Think, for example, that our Aptis demonstrator is rendered capable in terms of its airless performance thanks to breakthrough in new composite hybrid fiberglass and resin composites. Also, our work in developing biosourced alternatives to petrol-based elastomers, or our work to recycle materials such as PET, styrene, and carbon black, will find applications out of tires and inside tires, and will provide the key breakthrough milestone on our journey towards achieving 100% sustainable material rate in our tires by 2050.
In conclusion, our unique capabilities in designing innovative flexible composite structures are at the same time a way to leverage our R&D technologies to create growth avenues beyond tires, and in turn, by doing so, we are able to discover new technologies, new innovation that could be then be applied to our tires activities in order to develop the leadership of these activities of tires for the future.